Hello everyone, I welcome you all to this class. This is mathematics class, and today we'll be considering this uh, second example under this topic we introduced in our previous video, first order linear ordinary differential equation. We have started solving problems on this first order linear ordinary differential equation, and this is the general form of the first order linear ordinary differential equation. This is the general form of it, and this is the integrating factor. Let's look at this. This is making it the second example, right? Let's look at this problem. Now, this is initial value problem. So in this problem, you have to solve this ODE, and the initial value of the dependent variable at a point, at this single point of the independent variable here is t, because the one having prime is the dependent, x is the dependent, while t is the independent. So this x of -1 equals 2 means that remember x is the dependent, which means x depends on t, which is the independent. So this thing, you are having x of -1, which means that the value of the dependent variable at this single value of the independent variable is what? 2. So x takes value 2 when the independent variable t has value -1. So let's start the solving solution. Now look at the format. Look at the format here. The term having the dependent variable should be at the what? Left hand side. Then that function of the independent alone should be at the right hand side. So let's write down the equation given to us. Given x prime equals x divided by t plus 3t squared. So I'm going to rewrite this. This implies I'll move every other thing to, I'll move this term that has the dependent variable. Dependent variable here is x, because x is the one that has the derivative sign. I'll move this term to the right. So leaving the function of the independent. The independent here is t. Leaving the function of the independent alone at the right hand side, just like this. So I'll move this. So this implies x prime. If I move this to the left, it's changed to negative x of t equals 3t squared. So this implies x prime minus 1 over tx equals 3t squared. Is now if you compare this equation and this one, is now in that form it's supposed to be, right? So the dependent variable, the derivative of the dependent variable, which is this, x is the dependent in this case. Then this is the function of the independent multiplying the dependent, and this is this one, the function of the independent alone. So our integrating factor equals exponential integral of p of t dt. So this is exponential integral of, what is this p of t? Coefficient of the dependent. What's the coefficient? -1 over t dt. So this is exponential. -1 can come out of the negative, this negative sign can come out of the integration. I have negative integral of 1 over t dt. So this will be exponential. Now what will be this will be exponential, this will be exponential negative ln of t. That's what it will give you, because whenever you are integrating a function like this, integral of f prime of x divided by f of x with respect to x, the solution is ln of the denominator f of x. That's ln of the denominator. What this thing is saying is that whenever you want to integrate a quotient function, that's a rational function in fraction form, if you want to integrate it, if you differentiate the denominator and you are getting the numerator, so the derivative of, if you differentiate the denominator and you get the numerator, then the result of that integral is the ln of the denominator. For instance, now if you have integral of 2x divided by x squared plus 1, now for instance, with respect to x, this will be equal to ln of, I'm writing this because I know if I differentiate the denominator, I will get the numerator. Differentiate, if you differentiate 1, you get 0, right? Then if you differentiate x squared, you get 2x, which is what is at denominator. So the derivative of denominator is giving us the numerator. So the result of this integral is the ln of the denominator. So that's the result of this integral. So if you compare it with what this one we did here, now what is at the denominator is what? T. If you differentiate t, what will you get? 1. You get 1, which is what you have at the numerator. So the result of this integral is the ln of the denominator, ln of t. And we have negative, which we have factored out here. So we have negative ln of t. Log. We use the property of log. This is exponential ln of t raised to the power minus 1. Now if you have log a base b, if you have log a base b, then this can be written as what? A log of b, right? I can bring this a here, then log of b. Then just similar something here. You know, we have negative here. This is just like negative 1, right? Then if I want to, if that this one now is looking like this one, a log b, so I want to return it like this. So this quantity here, I will bring it on this b. What is our b in this case? T. This quantity here, which is negative 1, I will bring it on it. So I lifted it from here and bring it on t, on the index of t. So that's what we now have. So now exponential and ln, they are inverse function of each other, which means they will cancel each other. So they will get cancelled, remaining t raised to power negative 1, which is 1 over t. T raised to power negative 1 is 1 over t, right? Then this is our integrating factor. So you now multiply, let me call this one equation 1, because it is this one that has the general, we have put in the general form. That's the one you multiply by the integrating factor. So if you multiply here by 1 over t, you have 1, this implies 1 over t x prime. I multiply here by 1 over t. Then multiply this one by 1 over t. You will be doing 1 over t multiplying negative 1 over t x. What will happen? 1 multiply negative 1, you have negative 1. T multiply t, you have t squared x, right? Then equal to, then multiply this thing, multiply 3t squared by 1 over t. That's 1 over t multiplying 3t squared. What will happen? T will cancel one of this t, remaining 3t. So we have 3t, right? Now, from our previous, from the previous question we solved, I told you that once you have multiplied both sides of the equation by the integrating factor, then everything you have at the left hand side, all these things we have at the left hand side is the same thing as the derivative of the product of the dependent variable and integrating factor. What is the dependent variable in this question? X, because x is the one having prime. What's the integrating factor? 1 over t. So integrating factor is 1 over t. Multiply the dependent variable x with you derivative of it with respect to the independent. So this will give us all these things we have at the left hand side. We saw that, we proved that in our previous class. So this equals to what? We now equals to what we have at the left. Then after this, what do? We integrate. Why we are putting it in this form? Because if we put it in this form and put integral here, integral will cancel the derivative. So we'll put integral at the both sides. So if you put integral here, we have integral of the derivative of the product of the integrating factor and the dependent variable dt equals integral of 3t dt. So integral and the derivative will get cancelled. You will now have what this quantity inside. You have it back. 1 over t x equal to, what is the integral of 3t? 3t is same thing as 3t raised to power 1. According to the rule of integration, you add 1 to the power, 1 plus 1, and divide by that result, 1 plus 1, which is 3t raised to power 1 plus 1 is 2, divided by 1 plus 1 is 2. So you have, which I can write as 3 over 2t squared, plus the constant of integration, plus c. You include the constant of integration. So let me write the result we have here. So you try to make, you are looking for the solution of that ODE. So you are looking for the dependent variable, which is your x in this case. So how do we make x the solution of the formula here? We can multiply through by what? T. If you multiply both sides by t, x will make the solution of the formula. Multiply both sides by t, multiply here by t. If you multiply here by t, put t here, t and t will get cancelled. Remaining your x, we have x equal to, multiply here by t, we're having t raised to power 3. You have 3 over 2 t raised to power 3. Multiply this place by t, you have c multiplying t. Right? So we are going to use, what I wrote down here is using the initial condition, that is x of -1 equals 2. We have, because from the question, remember the question before I cleaned the question because of space. Remember I had that the initial condition was what? That x of -1 is 2. That is the dependent variable which is x takes value 2 at what? -1. -1 is just that single value of the independent t. So because this general solution is just like in this form, x of t, because x is the function of the independent variable. So x of -1, we'll put -1 here for t, which equals 2. They say it's 2, right? Will be equal to, what is this? We now have 3 over 2. T at that point is -1, right? -1 raised to power 3 plus c into -1. So this implies that 2 is equal to, you simplify this, -1 cubed is still -1. And -1 multiplying 3 over 2, -3 over 2. C multiply -1 will have -c. So what we are looking for now is c. We are looking for c now to get it. That's that constant of integration. That's what we are looking for. So I want to move c to this side. If I move t to the left hand side, it's changed to what? Positive. From negative to positive, I have positive c equals, I'll move 2 to the right hand side. So I have -3 over 2 before at the right hand side. If I move 2 to the right hand side, it changes to -2. So I'll now simplify this. This will be equals to, what's the LCM is 2 2 is sent as this 2, negative 2 is sent as negative 2 over 1. So 2 divided 2 is 1. Multiply negative 3, we have negative 3. Then 1 divided 2 is what? 2. Multiply negative 2, I have negative 4. So this is giving me negative 3, negative 4 is negative 7. Divided by what? 2. So this implies that my C. This implies that C is equals to negative 7 over 2. So that's C. C is negative 7 over 2. You now substitute, right? You substitute. Let me call this one equation 2 and call this one equation 3. We'll now say substitute 3 in 2. So we'll put this equation 3 in 2. So this implies that x of t will be equals to 3 over 2 t raised to power 2. Now replace this c with what we got, negative 7 over 2. So I'll write negative 7 over 2 t. So this is now the solution. So thank you so much for being part of this class. See you in the next class.